function of equation of the given graph. So we have this graph here, and we want to find a piecewise function equation. So if you look here in the domain, this is a quadratic function, is in the domain from minus infinity to 0, so including 0. It's obviously this is a x squared, but I'm just giving us some general form if we don't know, for example, exactly what it is a scaling factor. So let me give here the general form how we can find this equation of this graph. So we already know f of x. So we already know f of x is equal with a times the general form of the vertex form of quadratic equation is x minus h squared plus k. And now I'm taking here any point. So I'm looking at the vertex here. The vertex obviously we see is here. So the vertex is 0, 0. So x is 0, y is 0. So this is h and this is k. And now we are looking to take any point of this graph. We can take this point here when is intersected the grid, because we know exactly what is x and y coordinate. And we can take this here, either one. But let me take this one here, minus 2 and 4. So x is minus 2, and f of x is, or y is equal with 4. But in this case, I'm taking f of x because f of x is here. And now I'm moving a little bit, and I'm applying those inputs in this equation. So instead of f of x, I'm writing 4 is equal, here is a, and instead of the x here, I am plugging is a minus 2. So this is minus 2. And instead of the h is a 0. And this is squared. Instead of the k, plus k is, as I see here, is a 0. And now we have 4 times minus 2, minus 0 is minus 2, but minus 2 squared is 4, positive 4, times 4. And plus 0 is just 8 times 4. If we are dividing everything by 4, so in both sides, so a is equal with 1. And now if we are plugging in those values in this function, we can find the function f of x. So f of x is going to be equal, instead of the a is 1 time x, instead of the h is 0 squared, and k is 0. And this implies f of x is going to be equal with, as we see here, 1 times x minus 0 squared is x squared, times 1 is x squared, and x squared plus 0 is just x squared. So this is the function what we are looking for, what we wanted to prove. And this is the function that is in the domain from minus infinity to 0. And now the piecewise function, we can write this form. F of x is equal, so let me write here in the restricted domain, when is a x squared quadratic function, and in the domain when x is less or equal, because it includes a 0, is from minus infinity to the point 0, including 0. So we can write in this form. And then I'm going to look here to find in restricted domain from 0 to 2. If we are looking from 0 to 2, we have this function here. And this function we already know, y is equal with a 6, because intercept 6, and this is a constant function. So f of x is equal with 6. And now we can go down, and we can write this function in the piecewise function here. So here is a 6. So let me write with a black color. So this is a 6, and is in the interval between 0 and 2, but does not include a 0. So this is a open interval between 0 and 2. So this is open interval. And now I'm going to look for the last equation, for the last graph, to find the equation for this graph here. And if we are looking at this graph here, we already see we need here to find the 2 points in order to find the slope. And we have, let's say this is a P2 and this is a P1. So the P1, the point 1 is x is 2 and 1, 2 and 1. And point 2 is equal with 4 and 2, 4 and 2. So we can find the formally the slope, or we can find informally. If we want to find informally, so let me take a little shortcut. We already see the rise is 1 and the run is 2 units. 2 units here. So 1 over 2. Or you can apply the formula y2 minus y1 over x2 minus x1, which is going to yield the same result. And we take in the point form slope. And the point form slope formula to find the equation is y minus y1 is equal to the m x minus x1. Here I can take either point, but because this is a smaller, so I'm taking the point 1, and I'm applying in this equation here. So here is going to be y minus, I'm taking the point 1, and instead of the y, so let's say this is x1, this is y1. Instead of the y1, I plug in 1 here, is equal, but m is 1.5. We already have here m. And I'm using these two formulas, okay? And instead, now I have x minus, x1 is here, so is 2. And now let me simplify a little bit this formula. This equation, 1 over 2 times x is 1 over 2x. But 1 over 2 times minus 2 is going to be minus 1. I am subtracting both sides. I am adding both sides 1, and this is going to cancel. And now y is going to be 1.5 x. So this is the formula this is the equation for the graph, for this graph here, in the interval from 2 to 6, but this is a closed open interval because it includes 2 and goes to infinity, because this arrow tells us it's going to go to the infinity. And as a piecewise function here, we can write, let me change the color. We can write 1.5 x, and this is in the interval, so x is going to include 2, and it's going to go to infinity. Or in other way, we can write a little bit like we wrote this here. So let me write in a different form. Maybe it's better if I write in a different form. Okay, since I wrote this one here, so x is greater or equal to 2, if I want to write in this form.